Hey guys, this is going to be part one of kind of the two-part review for chapter one. The first thing I'm going to talk to you guys about is what you need to know for the chapter one test. I'm going to share this document here with you, the information that you need, so you guys have that. If you have any questions after you watch this podcast or the next one, or for anything for the test, just please let me know. We're going to have a help session tomorrow morning. I'm gonna get here around 6:30, so I'll be available from like 7 to 8:30, so that we're ready for our first part of our test tomorrow. So we're gonna go over some information. I'm gonna do some example problems, and hopefully this will help. The first thing you need to know for the chapter one test is how to disseminate information from a pie chart. So if you have a pie chart, let's just say this is the percentage of NBA championships. There will be a question that has something where you have to figure out some bit of information about this. There will be like 5 responses, and you have to figure out which one's the true response. So if I said the Boston Celtics and the Lakers make up half of the NBA championships, that would be an incorrect statement because that would add up to be 46%. So that's what I mean by disseminate information from a pie chart. You'll be given a pie chart and have to talk about kind of something about that and find the true statement. Another one is to find how to disseminate information from a bar graph and decipher incorrect graphing methods. So I'll give you a bar graph that might not be correct in the sense that if I start on the y-axis above 0, I'm doing that incorrectly. Because what this is showing that Democrats have a higher percentage who agreed than Republicans and independents, but it's really in reality not that much higher. It's only a difference of 8, where, I mean, this graph is showing that it looks like a huge difference. If I started at 0, it wouldn't look like that big of a difference. So that would be something where I'm talking about a bar graph in that sense. Finding IQR when given data. This one is more, you'll be given either a stem plot or just a data list, and you have to find the IQR of that. There's a couple ways that you can do that. The easiest way is to plug your information into your stat edit tool. I have a couple of different things going on. Let's just use list 1. If I find one var stats, I go to stat calc. One var stats for, I'll do list 1. You should be able to find the IQR, but the first thing you have to do is enter that data in, and then you'll come down here and you have Q3 and Q1, and you'll be able to find those two things, the IQR, pretty easily. Be careful, IQR is an actual number. It's not a range of numbers. So in this case, it would be 9.5, not from 15 to 24.5. Okay. Finding the general location of median and mean when given a distribution. I'll give you either a histogram or a stem plot, and you'll have to decide where the mean and median are. So what I'll do, and I'll kind of give an example of what this looks like. I'm gonna draw like a couple of lines. And I'm just guesstimating here. So let's say this is A, this is B. And you'll have to determine which one is the mean and which one is the median. Remember, the mean goes towards the skew, towards the outliers. The median kind of stays around that clump. So A would be the median, B would be the mean. That would be like a type of question that I'm talking about here. How to disseminate information from a two-way table. We're going to come back to this two-way table, but I have age and if you're a Facebook user or not. Basically, you really have to understand if these variables are associated. That's one thing, and that's looking at kind of like those conditional distributions. Obviously, the older that you get, the less likely you are to be a Facebook user. And then another thing, I'm going to ask you like a question, and there will be like 5 possible answers. You're going to try and pick the true statement. So just make sure you understand your definitions when it comes to a two-way table. That's the biggest thing for that. Um, know how to find the mean and median, how that changes when adding an outlier. Remember, the mean is not resistant, the median is. So if I have an outlier thrown in there, the mean is going to change, whereas the median will not change or change very little. Okay. Know how to find the mean when given some information. This will be a type of problem where I will give you something like this. I will say um, the average or the mean test score. All right, this is working. Average test score was 75. John took his test late and got a 100. How does this change the average of all 20 students? So with John, I have 20 students. Without John, I had 19 students. So what is the total value with those 19 students? So if I had 19 times 75, 19 times 75, that gives me the total value of those 19 students who had an average of 75. I'm going to add John's value and then divide by the total number. So we're trying to get the total value and then divide by the total number of students that we have here. And the new average would be 76.25. So if I was trying to find the mean, that's how I would go about doing that. All right. Definition of standard deviation. Remember, this is our kind of script problem. If I ever ask you to interpret the standard deviation, you need to know how to do that. You're going to need to know the definition. Remember, this is the average distance that your values are away from the mean. So on average, the typical deviation from the mean is whatever the standard deviation is. Okay? You got to know how quartiles work and how to get information from a 5-number summary. I have an example here that has just some data, a minimum Q1, median Q3, and maximum. So if I were to draw a box plot of this information, I'm actually going to do that down here because I don't want to do it twice. So if I have a box plot, let's call this distribution A and distribution B. We're going to do A. So 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 50, 40. All right, so if I have my minimum value, this is my box plot for A. My minimum value is 20. Q1 is 25. Median is 28. Q3 is 34. And this might be an outlier, but we'll get there when we see that. But what I need to know, what you need to know, and kind of what I'm asking for in a type of question like this, is in between the minimum and Q1 is 25% of the data. You got to know that. In between Q1 and the median is 25% of the data. In between the median and Q3 is 25% of the data. And in between the Q3 and maximum is 25% of the data. You have to know this information. You got to know that the quartiles median splits it up into fourths. Okay, so 25%, 25%, 25%, 25%. You got to know that information for this test. We'll ask a question that kind of plays off of that. All right, so I'm going to erase this real quick because we're going to use this dot plot again. All right, so what's next? Okay, how do you find outliers in a distribution? How do you find outliers in a distribution? So I'm going to go back up here. To find outliers, this is where we have to take 1.5 times the IQR, which in this case is 1.5 times 9. So that's 13.5. I take 13.5, add it to Q3, and then subtract it from Q1. No, 11.5. Okay, so that gives you a range of values that if you have a value that's outside of that range, you have an outlier. So if we have anything that's above or below, above 47.5 or below 11.5, you have an outlier. So our maximum value is a 50, so we know we at least have one outlier. What I will do is I'll give you an entire distribution, and you'll be able to figure out how many and which outliers, or which are outliers or not. Okay. The next thing is, how do I do parallel box plots? Okay, so parallel box plots is I'm doing them on the same scale. So if I was going to do B, I have A and I have B. If I did B, I'm going to make my box plot here, Q1, Q3, and median are there, and then my maximum is 30. Okay, there's my box plot. That would be my parallel box plots. Now, on this box plot here, box plot A, we have an outlier. We just figured that out. So you would have to denote that. If you were going to do this on the calculator, this is a different data set, so don't get this confused. But if I have second y equals, turn my plot on, we're always going to go to the dot plot that has the dots, okay? And if I graph it, if I have outliers, they will show up. I think I have outliers on one of my lists. Let me check. But what you can do if you have data given to you, you can literally just put this in your calculator and plot this data. It's perfectly fine. I don't know why this is doing that on the axis, but that would be what I would do if I have data. Okay. If I were to compare two distributions, that's either comparing these box plots, comparing histograms, something along those lines. You have to compare using SOX, shape, outlier, center, spread. Compare each one and use comparison words. The center of A is larger than the center of B. Use numbers. The center of A is 28. The center of B is 23. And you can compare center, shape, spread, outliers. Okay, make sure you do that if you're comparing or describing. How to construct a histogram. If I give you data, you can plug that data in your calculator. So if I have data, I plug it in. Okay, you don't have to plug it in and use your calculator. You can do this by hand. I think it's a little easier on the calculator. So I'm going to go ahead and turn this one off so we can see how to do a histogram. So if I go to second stat plot, turn this on, I'm going to go over to the histogram, which is the third one, and I hit zoom 9. It's going to populate a histogram and construct one for me. Okay, if I hit trace, these buttons down here can kind of help us out with where we are. So the minimum number, when I'm drawing this, is this tick mark. The maximum number is this tick mark. Okay, same thing, minimum is this tick mark, maximum is that tick mark. I would always go by this, and if you want to change your X scale at all to where it's a whole number, like these are whole numbers, sometimes that doesn't happen. If you hit window, you can change your X scale to a whole number, and that will change the way that your graph looks, and it'll just make it easier for you to just write it down, in my opinion. Okay. Explain which measures of center and spread would be best. That's when I take a distribution and look if it's skewed or not. If it's skewed, I'm using median and IQR. If it's not skewed, if it's roughly symmetric, I'm using center and spread. That would be your explanation. That would be how you describe which measure you're going to use. Okay. The last one that we're going to talk about is how do you calculate conditional distributions. If I was trying to find conditional distributions of Facebook users for each age group, what I have to do is first I have to find the totals if they don't give you the totals of the columns. Okay, find those totals first. And then to find the conditional distributions for the younger age group, for yes, I take 78 divided by 82. For no, I take 4 and divide it by 82. Okay? And I'm going to write those in percentages. This would be 95%, 95.1%. This would be 4.9%. Okay, and I do that for middle and older, and that's how I calculate conditional distributions. Okay, if I'm talking about describing the relationship, always talk about if there is an association or not. If these conditional distribution percentages are not the same, you would have an association. In this case, you can kind of already see as we get older, there are less likely to be Facebook users than the younger group. Okay, so that concludes kind of what's going to be on the test for Chapter 1. I'm going to talk about the review in a second in the second podcast.